All right, so we are on Unit 8, Lesson 11. Hopefully, you guys had a great 4-day weekend. Now we're going to be back at it. So it says, order the following pairs of coordinates from closest apart to further apart. Be prepared to explain your reasoning. Well, these are two, so they basically like start at the same spot, but they're a distance from 4 to 10 away. So these guys are 6 away. These guys have the same on 6, but they're from 5 to -3. It's going to be 8 away. These guys are both on -12. They're on -12 to -1, so they are 11 away. Okay, and these guys are both on 7, so they're from 0 to -9, 9 away. And these guys are both on -10, so they are 1 to -4 away, and that is 5. Now, the way that I'm getting that, in case you guys are confused, the way that I'm getting that is on the number line, so 2 is fine, just leave it. But from 10 to 4, so 10, 9, 8, 7, 6, 5, 4. That is 6 spots, 6 jumping spots away. Same thing here. From 5 to -3. 5 to -3. Well, 5, 4, 3, 2, 1, 0, -1, -2, -3. It's going to be 8 jumping spots away. All right, let's go to this one here. So still same thing. So the -12s were the same, but then there's a -12 here. So from -12 to -1, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And again, if you count your jumping spots, you would get 11. I'm going to circle these numbers because now my numbers are starting to blend in. Okay, same thing here. So from 0 to -9, you're going to count 9 spots. And on the last one, -10, so we have -4 all the way to 1. -4, -3, -2, -1, 0, 1. And that's going to be 5 spots away. So they want you to go from closest to furthest apart. Well, that's going to be E is the closest, A, B, D, and C. And that just goes numerically. 5, 6, 8, 9, 11. Now, let's flip it over. Question 2 says, name another pair of coordinates that would be closer together than the first pair on your list. So they've got to be, instead of being the first pair on our list. So E is 5 apart. We got to go to something closer together. So let's maybe try to go with something 4 apart. So start with any number. Let's say -7, comma, and then let's start our other one at -7. So now these just have to be 4 apart. So I can use 0 and 4, and they're going to be 4 apart. All right? Name another pair that would be farther apart than the last pair on our list. So our last pair was 11 apart. So now let's do the same thing. We can start, so let's just do 12 apart, because that's just one more. We can start with -7. Okay. Now what numbers would you put here to be 12 apart? Well, make it easy. Do 0 and 12. Awesome. Okay. Now 11.2. How far apart? Find the distances between the 3 points shown. Well, here's the deal. We can very easily find the distance from here to here. I'm going to draw the line. Because remember, these two numbers are the same. So how far is it from 9 to -3? Well, it's 12. All right, same thing here. Okay, the -3's are the same. So negative 14 to positive 16, sorry. So 14 to 16. And that's going to be 30 apart. But here's the one that might be a little bit more challenging. From here, I'm just going to draw a dotted line so you guys can see what I'm talking about. There we go. So how would we find out how far that is apart? Well, we're going to use the Pythagorean theorem. Okay, so the Pythagorean theorem says a squared plus b squared equals c squared. So I can find this by doing 12 squared plus 30 squared equals c squared. Now 12 squared is 144 plus 30 squared, which is 900. Add those together, so 1044 equals c squared. So then c is going to be the square root of 1044. Now I don't think that's a perfect square, but you guys can try it to see. Good. All right. So now we're going to use, so this lesson, or 11.2 is super important. When we get to 11.3, we're going to be using it like it's candy. Okay? So let's go ahead and look at it here. 11.3. So we have to use the Pythagorean theorem. So I don't know how many times I have to tell that to you guys. The Pythagorean theorem, like that's this whole unit. Pythagorean theorem. It even says perimeters with Pythagoras. My goodness, say that 10 times fast. So we've got to use a squared plus b squared equals c squared to solve these. Today's lesson might go a little bit longer, but that's because I want to make sure I show you guys everything. Okay, so which figure do you think has the longer perimeter? I don't know, that's hard because like these are long, that's short, but then these are consistently long. I'm going to say figure, what do you guys think? I'm going to say figure K. I don't know. I'm probably wrong, but we'll go with figure K today. All right, it says select one figure, calculate its perimeter. You don't have a partner, so don't worry about that. Okay, so figure K is what we're going to look at. We have to calculate the perimeter of it. How are we going to do that? Well, we're going to use what we knew from the last one. See how we connected those and made a right triangle? We're going to make a right triangle here. So we're going to go out and up, okay? And this point right here would be 4, and then 9. So now, based on that point there, 9, 4, we can figure out all these other things. So for example, we can figure out this length is 2, because from 4 to 2 is 2. We can figure out this one, because the 4's are the same. 9 minus 7, we get 2. So now the only one left to figure out is this one, which is the one we need for the perimeter. That's where we're going to do a squared plus b squared equals c squared. So I'm going to put this over here. So 2 squared plus 2 squared equals c squared. 4 plus 4 equals c squared. 8 equals c squared. Square root of 8 is c. So this one right here is the square root of 8. Okay, this side. All right, now, same concept. We're going to find this one here. So 9. Same concept. So this point right here is 9, negative 5. Okay? So now the negative 5s are the same. Between 8 and 9 is 1. Hopefully you guys can see that. Here, the 9s are the same. So 2 minus negative 5, that's going to be 7. So now I need to find this one here. So a squared, so 1 squared plus b squared equals c squared. 1 plus 49, 50, good. So this one right here is the square root of 50. There we go. All right, and on the last one, so it's kind of funny because they are so close, but they're just not quite. I'm going to do that one in pencil. There we go. See it? All right. Now this point here is going to be 7, negative 5. And you just know that from doing points, like from like 6th grade when you did the points and stuff, maybe even earlier. So the points, I'm not doing anything new to find a point on the grid. All right, so negative 5s, there is between 8 and 7. This is going to be 1. Now, this is between, because the 7s are the same, 4 minus negative 5, that's going to be 9. So if I do it again, a squared plus b squared is c squared. So 1 squared plus 9 squared equals c squared. 1 plus 81 is c squared. 82 equals c squared. So the square root of 82 is c. Good. Square root of 82. All right. So now for figure K, let's go ahead and add our square roots together. So we get square root of, so for our perimeter, because the perimeter is all the way around it, square root of 82 plus the square root of 8 plus the square root of 50. Okay, so square root of 82 and square root of 8 is square root of 90 plus square root of 50. That's square root of 140. So now do that in your calculator. So 140 square root. And I got about 12. So I'm wondering if I did that wrong, so hold on guys, because I got a different answer. So let's do the square roots separately. 82 square root. I'm just comparing the way that I did this. It's 9, 8 square root, about 3, 50 square root, about 7. Yep, so I did it wrong. 9 plus 3 plus 7 is about 19. You cannot combine the square roots. I did that totally wrong. Just do each square root separately. So just hear how I did the square root of 82 was about 9. Square root of 8 is about 3. Square root of 50 is about 7. I got 19. Okay. Now, just so you guys know, the other one had a perimeter of 18. So we were right. Now, if you want to, you're welcome to go ahead and do these just like we just did the other one. That's great for extra practice. Totally up to you, but this is what we're going to be doing. So if you want to take the extra chance, take the extra time and do it, that's a great idea. You can go ahead and do that with these. Okay, so it's up to you. Do whatever you want. Let's go ahead and we'll go to 11.4, but if you choose to do the other one, that's fine. All right, finding the right distance. Now this one is basically exactly what we just did with that other one. It says, have each person in your group select one of the sets of coordinate pairs. Well, we don't have groups. So, then calculate the length of the line segment between the two coordinates. Once their values are calculated, have each person in the group briefly share how they did their calculations. Okay. How does the value you found compare to the rest of the group? In your words, write an explanation to another student how to find the distance between any two coordinate pairs. All right, we're going to do this together. All right, we're going to do the first one together. So -3, 1, 5, 7. We're going to draw a right triangle just like we did before. So we've got to go all the way here and down here. Okay. Now, these ones we can tell the distance. So this point here, remember, is going to be 5 because it goes over 5 and it only goes up to 1. So the difference here is going to be the 5's are the same. 7 minus 1 is 6. Now here, the 1's are the same. So 5 minus -3 is 8. So we're going to use the Pythagorean theorem to find this one. So a squared, so 6 squared plus 8 squared equals c squared. 36 plus 64 is c squared. So 100 equals c squared. Square root of 10 is, 100 is c, and 10 would be c. So in that first one, you get 10. Now I want you, on your own, to do just like this. I want you to do the third one, okay? So go ahead and do the third one down here. I'm going to do my own. I'm going to pause the video. All right, now how you should do this, so see I drew it out. You're going to want to connect your lines. So, and you can connect it this way or this way. I'm just going to go this way. Now you guys hopefully had brought some graph paper home because that would super duper help you. Okay, this is -1, comma, -6. Okay, so to find our distances, the -6, they're the same. So then 5 minus -1, that's 6. This one here, the -1's are the same. 2 minus -6 is 8. So I'm going to do 8 squared plus 6 squared equals c squared. So 64 plus 36, 100. Square root of 100. So that is 10. Again. So if you want, now this is totally up to you, you can do the other two. I'm going to tell you the secret, okay? And you can do the other two, see if you're doing it right. All distances are 10, okay? In your own words, explain how to find the distances between the two coordinate pairs. You can totally explain what we did here, okay? So do a step-by-step process. 1, draw a grid. 2, plot points. 3, find point that connects both of them. Like we did here, see that point? And then 4, use Pythagorean theorem. Okay, so today's video went pretty long, guys. I am so sorry about that. Read the lesson summary, please do the practice problems, and have a wonderful rest of your day.